Hello and welcome to the Blue Open Studio tutorial video series. The topic of this video will be communication drivers. In this video, we will be discussing the comparison of the main driver sheet and standard driver sheet capabilities, properties of the main driver sheet, properties of the standard driver sheet, description of the driver runtime and driver worksheet priorities, and then we'll be demonstrating adding a driver, configuring driver-specific settings, configuring the main driver sheet, configuring the standard driver sheet, finding and displaying driver documentation, and adding duplicate drivers. In Blue Open Studio, there are two different driver worksheets that are able to be configured. The first is the main driver sheet, and there's only one of those per driver. And then we have the standard driver sheets. We can have up to 999 of these. Neither one are required for use, though, in a Blue Open Studio application, meaning that you could create an application without any driver configured at all, and the application would still operate. The maximum size, meaning the number of lines or number of tags that can be configured in the driver worksheet, is not limited for the main driver sheet, but it's determined by the driver. And both driver sheets can be enabled or disabled depending on how you set up the triggers. Triggering for each one is different, and we will go over those when we discuss the properties of each worksheet. You also have a status where you can configure tags to read the status and completion of reads and writes for each driver sheet. And for headers, meaning the file types, for example, in Allen Bradley N7, it is whatever supported by the device in the main driver sheet, and for the standard driver sheet, there is one header per driver worksheet, meaning that if you need to go to an Allen Bradley and you need to communicate to, say, N registers in N7 and then T registers in T20, you would have to set up two different standard driver sheets to do that. And both can read, write, or read and write to or from tags. The station basically is the communication string, IP address, port, slot number, things like that. They can be fixed or a string tag for both. The scanning rate or scanning type can be always, and for the main driver sheet, you can configure that also to be screen. And we do have a scaling option in both for minimum and maximum, but also to scale between division, multiplication, addition, and subtraction. So what we will do now is we'll add in the communication driver that we're going to be using for our test application. On the Project Explorer, click on the COM tab, and then up at Drivers at the very top, right-click, and then click on Add Remove Drivers. You will see a communication drivers list show up. On this list, you have two sections, the available drivers for the software and the selected drivers that are currently configured or loaded into your application. These two fields are broken up into two columns. The first is DLL, which has a 4 or 5 digit code for the driver. And then the second is the description that tells you which driver it is. For this training application, we're going to use the Modbus TCP. So we want to go to M and find MOTCP. We just select it, click select, and it adds it into the selected drivers. Additionally, you can also double click and it'll add it in as well. And if you ever need to remove one, you would just come here, highlight or select the one under selected drivers, and either double click or click on remove. Once we have our driver selected, just click OK. And now when we expand the drivers group, we see MOTCP. Now what we will do is we'll look at the driver specific settings. And to get to that, we'll just select the driver that we want to set, right click, and then select settings. And what this does is this brings up the driver specific dialog box. For MOTCP, we see that most of it is grayed out because it's for serial communication. Since this is an Ethernet driver, the majority of that is already pre-configured. You do see down at the bottom you have your signed or unsigned value, the protocol, swap, block size, and max gap settings. In addition, the invocation identifier, these are specific for Modbus, and if you need to configure them, we'll show you exactly what the settings could be when we look at the help documentation. So now we'll click on Advanced, and we'll look at the advanced settings. Here we have things like the timeout for start and end messages, the retries. You would also configure your station here if you were using a serial driver. And then you have your buffer length for transmit and receive. And at the bottom are the simultaneous requests. Unlike in GP Pro EX, we can configure how many requests are made per station and also how many requests are made simultaneously for the entire driver. And think of this like a pipeline for water. The maximum is this very large pipe that all the water flows through. The maximum per station are much smaller pipes that would fit inside of this larger one. So for example, the maximum can only hold as many pipes as will fit. So you need to make sure you configure these accordingly. So if we have, let's say, 5 stations or 5 different devices we need to communicate to. If I put in here 2, that means I want 2 simultaneous requests per station. In order to get all 10 of those, because 5 stations times 2 is 10, I would have to set maximum to 10. If I set it any lower to 8, then what it would do is it would make 1 request per station, and then the first 3 stations would get an additional simultaneous request, and then 2 would be left out. This is something that you need to keep in mind when it comes to troubleshooting communication speed. This is a good thing to look at, but also the higher the simultaneous requests, both maximum and maximum per station, the more processing or CPU utilization that the application will take. So there is a trade-off on how these are set. For us, we're just going to leave it at 1 maximum and 1 per station. We click OK, and we click OK. We will now look at the properties and how to configure a main driver worksheet. But before we do that, we have to add a member to one of our classes. So we're going to go under Project Explorer to the Global tab, expand classes. In this case, it's going to be the C driver class. And then I'm going to click on Datasheet View to bring it up. And I'm going to add a new member called Station. And I'm going to make that a string. Once I have that added, I just close the worksheet. And then I will come back to the COM tab. And then I will expand MOTCP, and I'll see a main driver sheet entry there. And I will simply open it by double-clicking. Anytime you add a driver into an application, the main driver sheet is automatically generated. Now, you don't have to use it for communication. You could leave it blank, and then it's simply just not attempting to communicate to any device. The driver sheet is broken up into 2 sections. We have the header at the top, and then the body at the bottom. We have in the header a description field. We could change it from main driver sheet if we like. I'm not going to. Then we have a disable field. And we'll see these throughout Blue Open Studio. And how they work is they evaluate whatever tag or value or expression that is put into this field. And if that evaluates as true, then it will disable communication for the driver. In Blue Open Studio, a true-false is not like it is in GP Pro EX. A true value is any non-zero. So 1, -15, a fraction, a decimal, any number other than 0 can be true. And then a false value is 0. So if whatever expression, tag, or value you put into the disable field is not 0, it will then disable communication for the driver. For us, we are going to add a tag in here. And there's 2 ways to do it. We can first type in the tag, or if we right click, we can select Insert Tag Expression. This brings up the Object Finder. And the Object Finder allows you to sort the tags by the project, tags that you've created, system tags, any available functions that you may want to use. In this case, we're going to select project tags, and then we're going to highlight the MDV class. And at the top, you see I can select member, and it brings up a list of all of the members for that class. And in this instance, I'm going to select disable, then click OK. And now you see that the mdv.disable tag has been put into the disable field. Then below that, we have the completed and status fields for both read and write. And how these work is for completed, we would enter a tag. So in this case, I will insert a tag. It'll be MDV again, and this will be read_COMP, and click OK. And the completed field essentially toggles the value of that tag between a 0 and a 1. Now this is simply that a read or a write has been completed. It doesn't evaluate the success of that. It simply says that I've completed my last read or completed my last write. In order to get what the status or the result of that last action is, we would have to put a tag into the status field. So we'll right click, insert tag, select MDV again, go into member, and in this case, since it's the read, I will select read underscore STAT. Click OK, then OK again, and now you see that I have my tag in here. And now this tag will store the value of the last read that was completed. A 0 means it's good, and any number of other values could be any different type of error or status message. And they vary based on the driver. So when we look at the help manual for the MOTCP driver, I will show you where they're located. Now I'm going to go ahead and complete the rest of the fields. Okay, now I have the write completed field and write status field entered, and these work the same way as the read. They're only for the write action instead. And now down in the worksheet body, we have several different columns that we need to configure. We first have the tag name, which will be the tag that will receive this information inside of Blue Open Studio. Then we have the station, and this can either be a static value or a tag that stores the IP address or communication path for the specific device we're communicating with. Then the IO address, and this is now the IO or the register on that device that we're trying to either write the data to or read the data from. We have an action, meaning whether we want to just do a read, a write, or a read and write. And then there is the scan, and there are 3 options here. And those 3 options are screen, always, and auto. If you select screen, it will scan for that tag or read to the device and receive the information or write the information to that IO address, only if that tag is being displayed on a screen that is currently open in the runtime. With always, regardless of where that tag is used or whether it's being displayed on a screen, it will always scan for that. So it will always get the information for that. This is useful for things like alarms and sampling or trending. Auto, this one is a little more tricky. How auto works is the project will automatically choose either to set it as always or to set it as screen, depending on where the tag is used in the project. So essentially the application or the software goes through and it looks to see where this tag is used and it selects it appropriately. So now what we'll do is we will add in the fields for the worksheet body. And the first one I'm going to do, I'll right click and select insert tag. And we're going to select main PLC array. And I just simply, once I have it selected, click on index. And now I can select what index number I want. In this case, it'll be 0. Click OK, and then OK again. Then for the station, like I said, this could be a static value like an IP address, or we could put a tag in here. The problem is if we right click, we do not see the option for insert tag. This is because this is a text field, meaning that even if we put text in there, it would read it in as that actual value. So what we have to do is we have to manually enter in the tag inside of curly brackets. So if I do open curly bracket and then type mdv dot station and then close curly bracket, now I've entered a tag in for that field. The IO address is configured differently in Blue Open Studio than it is inside of GP Pro EX. For example, we require having a header and then the offset or the address versus the straight value. So if I want to configure this tag to read register 40,001 from the device, instead of typing in 40,001, you see that I get all of a sudden a 0x:1. I have to put in a 4x:1. What this means is it's looking at the header or file 4, and then the colon means it's a separator from the file type, and then the offset. So the 1 is the offset, so the actual address starting from 0 that I want to read. So this is 40,001. I'll leave the action set to read and write, and I'll leave the scan set to always. Now that I have the first tag entered, for the rest of the tags, I will be copying them out of an Excel file. And in a previous video, we downloaded and extracted a zip folder containing several files we'll be using when we're creating this training application. If you haven't downloaded it, there is a link in the description of this video so you can download and extract the file. So I'll first open Windows Explorer, Go to the C drive, and then to BOS training files. We see BOS training tags.xls. Open the file. I'll snap it to the right of my screen. Go back into Blue Open Studio. Snap that to the left. And as you can see, the Excel file is laid out in the similar format as the main driver sheet. And I am just going to copy lines 4 and 5. Copy them out of Excel. Paste them into the driver sheet. And they came in without any issues. And if you looked at the using tags tutorial video, you saw the same process that we use there. As long as the syntax of the information is correct and the order of the columns is correct, you'll be able to copy out of Excel and bring it into the worksheet. And this holds true for any feature in Blue Open Studio that uses a data sheet or worksheet view. So alarms, trending information, we saw it with the tags, and of course with communication for driver sheets, and when we get into OPC and DDE, you'll see them there as well. And as long as this information is formatted that way, you'll be able to copy out of Excel into Blue Open Studio and vice versa. So for the next tag, I will be entering it manually. So I'm going to type in backup PLC, open bracket 0, close bracket. And now for the station, I mentioned previously that it could be a tag similar to what we put in for the top 3, or we can enter a static string. This could be an IP address, this could be the port number, this could be any routing information we need to get to the device. Since we're using Modbus TCP, I'm simply going to enter in the IP address of 192.168.1.100. For IO address, 4x:1. I'm going to leave the action at read and write and the scan to always. And then for the next two, I'll come back into the Excel file, copy lines 7 and 8, and paste them in. And I will maximize Blue Open Studio so we can see the full worksheet again. And now we have our 6 tags entered into our main driver sheet. Next, we'll look at a standard driver sheet. To add one into our application, we have to right-click on our selected driver, in this case MOTCP, and select Insert. Then we see the standard driver worksheet appear. It's still laid out similar to the main driver worksheet, just with a few differences. There's still a header and a body. However, the first thing you'll notice is that the header contains a few more fields than the main driver worksheet did. We still have a description field, which we will enter in the name of alternate PLC. And then we have a checkbox off to the right that says increase priority. We will go over that in a second, exactly how that works. Below the description, we have several fields, triggers for both read and write, and 2 more fields for triggers, which are enable read when idle and enable write on tag change. Both the read and enable read when idle can be used at the same time. Same holds true for the write trigger and enable write on tag change. How these work is we simply would add in a tag to each one of these fields. So for example, for the read trigger, I'm going to go in and select SDV class. And for my member, I'm going to select read_trig. So now, whenever that tag changes value, it doesn't have to toggle between 0 and 1. We could increase a count. So for example, you could put a second counter in here. It will trigger a read of any tags on this standard driver worksheet. How enable read when idle works is any value that's put in here that evaluates as true, once again a non-zero value, it will squeeze a read command in on a free cycle. How most communication works inside of devices or PLCs and HMIs, there is a read in, you do the process, and then there's a write out. During that time, it would try to squeeze in an additional read whenever this field evaluates as true. So in our case, we're just going to put a 1 in here. And then for the write trigger holds the same properties as the read, meaning that whenever this tag, in this case sdv.write_trig, changes value, it triggers a write for this worksheet. Enable write on tag change. This field evaluates true and false as well, so we're going to put a 1 in here because we want to enable it. Whenever any tag on the worksheet body changes value, it writes that value back to the device or to the station. Then we have our read and write completed and status fields, and these work the exact same way as they do on the main driver sheet. So now I'll continue configuring these fields. And now below those we have a station and a header field. And the station field is just like the station column in the main driver worksheet, only this time we have a single station per standard driver worksheet. And just like the station column for the main driver sheet, we don't have the option for adding in a tag because this is a straight text field. So we have to add a tag in inside of curly brackets. So for this example, I'm going to type in both an open and close curly bracket, and then I'm going to type into the middle sdv.station. And then for the header, this is similar to how the IO address field was configured on the main driver sheet. For example, the very first one we entered in had an address of 4x:1, so that was 40,001. In this case, we're putting the header or the file type that we want this main driver sheet to use. So in this example, we want these to go to the 40,000s or the holding registers. So for a header, I'm going to put in a 4x: and then a 0 because I want it to start at 0. So that would start at 40,000. If I wanted to say start at 40,100, I would simply add a 100 in. This is the starting file or starting register for the worksheet. It's not necessarily the starting address. But in our case, I just want it to be 40,000. And then the body set up similar to the main driver sheet. We still have a tag name and an address field. And then for scaling, division, and addition. So the first one we're going to enter in, I'm going to right click and select insert tag. I'm going to select alternate PLC, value of 0. And for the address, I want this to be 40,001. And since our header says that we're starting at 40,000, just have to add a 1 in here as the offset. And if we wanted to do some scaling with division or addition, we could. You see there's only 2 columns here, one for division, one for addition. If we want to do multiplication, we'd simply divide by a fraction or a decimal. If we want to do subtraction, we'd simply add a negative number. We're going to leave those blank though. So I'll finish configuring the body of the standard driver worksheet. And to do that, I will go back into that tags Excel file. So open Windows Explorer, go into the C drive, go into the training files folder, and open the BOS training tags.xls file. And then I will snap it to the right of my screen, go back into Blue Open Studio, snap it to the left, and I will be on the communication drivers worksheet. I'll just copy lines 14 and 15 and paste them in. Then I will maximize Blue Open Studio. Now you see that I have my 3 tags configured with the addresses. With the way that the header is configured and the way that each of the address fields are configured, my header tells me that I am pointing at a starting address of 40,000. Alternate PLC array element 0, it is looking at 40,001. Alternate PLC array element 1 is looking at 40,002. And alternate PLC array element 2 is looking at 40,003. If I wanted to change this, let's say instead of 40,000, I wanted to look at 40,100 as a starting address, I would enter that in there. And now this one is 40,101, 40,102, and 40,103. When configuring the standard driver worksheet, we saw the increase priority checkbox. And how this works is it will help increase the importance of communication for a specific driver worksheet. With the diagram, what it shows is we have the driver runtime, which is the background task of Blue Open Studio, and it's driver.dll. And then we see the 4 different priorities or different threads for messages. And then the green cylinder is the driver messages queue, essentially how all of the messages get queued up in order for sending or receiving through the driver worksheet to the device. And then we go through the individual communication driver thread or threads, and that is the driver name.dll. So how the priorities are sorted is priority 1, which is the highest, is any standard driver worksheet that has the increased priority box checked. This is any command, be it a write or read trigger, a write on tag change, or enable read when idle. As long as that increased priority box is checked, it now becomes the highest priority. And then priority 2 is a standard driver sheet write on tag change and any write commands from the main driver sheet. Then priority 3 is the write or read triggers from a standard driver sheet and a read from the main driver sheet. And then the lowest priority is a standard driver worksheet with enable read when idle. And what this is typically used for is, let's say that you only have a specific command, say a read for recipe information. And you only need to do it at a specific time. And let's say that's when a button is pushed. But you need that information as soon as that button is pressed. This is where the increased priority box would come in. You would simply give it a read trigger based on that button, configure your tags and check that box. So now that driver worksheet is at the top of the priority list. As soon as the read trigger toggles, it will then read those in before it does anything else. One caveat to this is if you would check the increased priority box for more than one standard driver worksheet, it falls back to this priority order here. So let's say, for example, we have 5 worksheets and 2 of them have the increased priority box checked. What it would do then is it would first run those 2 based on this order. So let's say that the 2 standard driver worksheets, one is a write on tag change and the second is a enable read when idle. It would first do the write on tag change and then the enable read when idle. When those 2 commands are processed, it would then do the other 3. We will now show how to access the driver help file in Blue Open Studio. There are 3 methods for accessing this PDF file. The first is the easiest, and that is to go under the Project Explorer on the COM tab, right-click on the driver, and then click Help. That will open the help file, and all of the driver help files are laid out in a similar fashion. We first have our revision for the document and the driver version number at the top, and then a breakdown of several different specifications and configuration settings. The most important ones typically are the device specs, and then configuring the communication settings and the driver worksheets. And then at the very end, we have the troubleshooting section. So if we look first at device specifications, we see that for establishing communication, target device must meet the following specifications. It gives you the manufacturer, any compatible equipment, any device runtime software requirements. Then it also gives the network specs and driver characteristics, meaning the files for the driver in Blue Open Studio. And these we will discuss in a few minutes. And then it also gives specifications for the following registers. And these correspond to the header that we configured in the main driver sheet and the standard driver sheet. And then we have the configuring the communication settings, which we went through earlier in the video. And this provides information about how the driver communication and the advanced settings need to be set and what the available configuration settings are. Then we have configuring the driver worksheets. First, it's the main driver sheet, and this gives not only an explanation of the header and the body, but also supported data for each field. For example, in the station field, it gives us the syntax that we can use, which is the IP address, port number, PLC ID. Then it provides an explanation of each one of those pieces of data. Then we have for the standard driver worksheet, it gives the same type of breakdown with an explanation of the header and the body, and then an explanation of the station and the header and address fields. And then it gives a table that lists all of the data types and address ranges that are valid for the Blue Open Studio MOTCP driver. And then it provides a table that gives you a quick reference of how the header and address for the standard driver sheets can be configured. Then at the bottom we have the troubleshooting section. And this gives you a table of all of the error messages or status messages that are specific for the driver. These error codes will appear in the tag we configured for either the read status or the write status, depending on which action is occurring. So for example, if we get a value of 3, we see that the description says illegal data value, and then it gives us a possible cause and a procedure to solve. The second method for opening the driver help file is still under Project Explorer in the COM tab. If we right-click on drivers, select Add Remove Drivers, on the Communication Drivers dialog, we can then select a specific driver and then click on Help. What this will do is this will open the help file for the driver we have selected in that dialog. This is a great way to take a quick look at the help file for a driver we do not have configured inside of the application. And then the last way is to navigate to the help file in Windows Explorer. And a quick shortcut to get there is, once again, if we go down to the database spy and we type in the built-in function get product path, open and close parentheses, we then see a value show up. And this is the directory for the installed files for Blue Open Studio on your PC. So if I copy that field, open Windows Explorer, paste that in. Now I come into the Blue Open Studio program directory, and then if I open the DRV folder, we now see all of the files for each driver. So then if I navigate to M and I find the MOTCP driver, we see the 4 files. The DLL, which is the actual driver file, the INI, which is the configuration file for the driver, then the PDF, which is the help file that we just viewed, then there is an MSG file. And if I were to open this in Notepad, see that I have a list of the same error codes that I saw in the help file. This is a great accessory file that you can use for creating your own real-time troubleshooting. Based on the value of your status tag for a read or write, you could use functions to read this file in, find the appropriate code, and display the associated message on the screen to tell an operator exactly what the communication error is that you're seeing, other than just a simple numerical value. We will now demonstrate how to add a duplicate driver into a Blue Open Studio application. So let's say, for example, you needed to use the ABTCP driver, which is the Allen Bradley Ethernet DF1 protocol. In this driver, the one problem is you have a PLC family that you have to select. So for example, if we needed to communicate to PLC 5s, and we click OK, now this driver can only communicate to PLC 5s. Let's say we also needed to communicate to SLC 500s, and we needed to use this same driver. We wouldn't be able to because we only have one of them. Well, if I were to go back into the application or the program directory, go into the DRV folder, and if you recall, when we discussed it, we have these 4 files: the DLL, the INI, the MSG, and the PDF. If I were to simply copy and paste them, and then change the name, if I come back into drivers and I go to add a new one, I now see my newly added ABTCP2 that I can then select into the application. And now with this new one, under my settings, I can select the SLC 500, or if it's a PLC2, whatever the case may be. I now have 2 of the same driver, 2 identical drivers that now can be configured differently. This, however, does still count against your driver total for your license. So for example, if you were to have a license with 4 drivers, if you're using this application right now, 3 are configured, so you could add 1 more. This doesn't omit it from count. It simply allows you to add a duplicate of a driver in case you needed to configure one differently. Thanks for watching. If you have any questions, please feel free to contact ProFace America Technical Support by phone at 1-800-289-9266, option 2, or by email, support@profaceamerica.com. You can also visit our website, profaceamerica.com, for manuals, drivers, product FAQs, and other product and software information. Thanks again, and have a great day.